Okay, let's get into lecture 3. We left with kind of a cliffhanger in lecture 2, and you went off to do a quiz, looking at some budget information and answering a couple questions there. But we kind of left hanging the idea that, well, if adding a hired labor activity is good and gives us some detail that can be fruitful, and actually did show us that um, $6 is a bigger amount than we're getting paid for, internally, that the returns to the farm are giving us less than $6 for our own labor, the family labor, that looking into an activity that says let's sell some labor could be useful. So that's what we're going to do in this lecture as we move through. So the new question for us in model design is less than $6 a good return for our family labor. That's what we're getting. We don't know the exact number, but we know it's less than that. The accounting assumption in the budget was a market rate of $6. So we're not even making good on that amount. Okay, and so when that budget information that I showed you said assume $6 charge, and that's how we costed our family labor inside of the budget that gave us the lower activity coefficient here, 153, right? And so if we just look at that, you'll see that part of the issue here is changing the solution is if we use this gross margin all the way down here that includes the labor, it's taking on a fixed charge for the family labor of $6. The model is saying that's already been provided to you. You're going to earn your profits from the allocation, and now you have to decide at the end, should you follow this plan for corn, soybean, and wheat? But part of the plan is also, should you be allocating this much labor to the farm, this much family labor? And so as you might imagine, we're going to keep working on our model and try to get at an answer to that question. Should we offer to sell labor owned by the family to the market? This is a huge issue, right? So modern farm management has become sort of a pluri-activity. I don't have no idea if I'm spelling that correct, but you don't get a spell check, I don't think, if you use a dash in a word. So it just means multiple, right? So you're not only doing farming activities, but you're doing other entrepreneurial things that could be value added, right? So you're adding enterprises, but you're also commuting and working off the farm. And so it could be the case, something like 85-95% of income from a lot of farms, from a huge number of farms, comes from off the farm. So there's some kind of split that we should be accounting for here. And, normally in a farm enterprise plan, we wouldn't think about it except for the fact that there's this big number of hours, I don't know, 80% of a year being allocated to the farm. And the way we're allocating it right now is as sort of ordinary labor. We're not saying it's managerial time. And it's getting this low return. And so we need to ask, how would we model it? That's what this module is about. How do we do it? How do we make these things enter into our model and work? Well, the question itself about what should we earn, what should we get, it always would require, obviously as a question, it requires outside knowledge, not in our budget. And to know about the true opportunity cost of the family time being allocated to the farm, you need to know something about skills, flexibility for working hours, the commuting options or the commuting requirements. Those are the things that determine what kind of offers, wage offers, some family labor unit might get in the market. It could be the case that 1,700 hours is left over. This person could be working 2,000 hours off the farm already, but having trouble finding a second part-time work, and so this could all be allocatable. This farm work could be sort of the residual. We don't know yet, but for right now, we're doing the economics and we're trying to figure out, is there some kind of sale pattern that we would substitute, sell our labor to the market, hire in labor, and make some better margin. What information do we have? Okay, if we don't have enough to do this and figure out how much education have you had, what are other people earning, the one thing we do have is a model that tells us what they are earning on the farm. So we know what the returns to this are going to be. We know that from sensitivity analysis, and we know that if we want to flex this out and solve this model over a bunch of different alternative assumptions, then we could actually look at in detail what the labor returns on this farm look like. And that's what I did. So I ran a set of successive experiments changing the right-hand side of the family labor constraint from 100 hours to 300 hours, on and on, all the way up till it looks like I got to 1,700 hours, and then I tried one more at 1,800 when I got a switch. And you'll see this is what we're getting paid. So the first, I guess, yes, 700 hours, you're getting a huge return for labor supplied to the family farm, $66, $67. And it's $6 more than, I also put in the hired labor activity and got the shadow price for that as well. You can do these experiments, right? That's why I listed them here. Just put 100 in for the right-hand side, solve, look at the sensitivity report, and read the shadow prices. Change it to 300 and do it. It's a little tedious, and I didn't want to require you to do it, so I did them all. But this is what you end up with. So the gap here is exactly $6 because the way the model looks at this, family labor comes to me for free. I don't pay anything. There's no outlay for it. Hired labor comes to me at a charge of $6 per unit. And so I'm hiring in labor here. The family labor is preferred because it has zero outlay with it. But they have the same pattern, right? So there's always going to be this constant gap. And so you're getting $67 an hour, 61, up to 700 hours, and then the model flips, okay? The labor after that point drops down, and this is about, I don't remember the actual number, maybe $1 or something. It's not much. So this shadow price for, maybe it drops all the way to zero, sorry. So that drops to zero, and $6 becomes the new shadow price, and so it's not perfectly informative here because that shadow price is completely contingent on the fact that if for some reason you lost an hour of family labor, the thing to do would be to swap in a hired hour of labor, and that costs exactly $6. So those shadow prices get linked together, and that's one of the things, and we'll talk about it a little bit later, how these kind of activities end up becoming linked together so the shadow prices move together. But let's follow the blue line, and eventually you get all the way out to 1,700, and beyond 1,700 to 1,800, I think the shadow price falls to something like 60 cents an hour. Okay, so we're at a very low amount here, and then out here we're at something like less than $1. So family labor shadow price $6. It's plus 6 over that one everywhere, over the hired labor. The high return only lasts for 700 hours though. And so what we really need to be asking is, are we okay with this blue line here, or are we willing to go out and see if we can earn higher amounts out here? Because if we can earn $10 here, we could pay off the orange. The orange would cost us 6, right, the hired labor, and we'd have 4 net, right? It would be a higher return. So really we're just asking, can we beat the market rate by selling our labor? Can we replace ourselves on the farm, pay $6 to replace our hours? That's hard to say, hours. Can we do it? And so we might do that. We might try a model, and it's pretty simple. You have labor hire, just add selling labor. 3 activities go to 5 activities. Well, we had 4 activities. We had labor hire before. So let's just sell our labor, and we're going to put a charge of $12. And I don't know why I have that number, but let's say that was what we consider to be the opportunity cost. Maybe we have 2 years, 4 years of college, and we think that's what we should be getting if we're going to sell labor off the farm. How do we put it in? Well, the same way that corn, soybean, and wheat uses up family labor, selling labor to the market would use it up, right? So we put in a positive coefficient of 1 here to say that, okay, if you're going to be using up 1,700 hours, you use 3 every time you plant corn and harvest and sell, 240. Every time you sell an hour to the market here, you're going to use up 1 hour. Okay, and then we still have the labor hiring comes in to supplement, and so what we end up with is a model solution that grows the objective, right? I don't remember what it was before, 102, it grows it by 7,000, So we're getting a higher return. We're selling off labor to the market. We're hiring in the maximum amount of labor. So we're hiring in a full 900 hours, and that's really what's going to limit how much labor we sell to the market. So we add that selling labor activity in. We put $12 in. I just wanted it to be something bigger so that you would see it. Obviously, that's a number we would want to have a good idea on what the offers we could get would be. It adds net revenue to the plan. It uses 1 hour of available family time. We need to know if we did it correctly. Do we have a model here that accurately represents the idea of, I want to sell my labor to be replaced on the farm by hired labor? Did we do that? And so I have a test proposed that I want to try, and I'll ask that you do it before you continue in this video. So pause the video and do this with me. Set the right hand side of the available hired labor down here. So notice that this is now binding. We could look at the sensitivity information, but I don't want to do it that way. I want to run a test. So take this model if you need to. I think you have the sheet for it. Put 10, yeah you do, sorry. I'll talk about it after we've paused everything. 10,000 hours on the right hand side. Run that and look at the solution and see if you can figure out what the problem we have is. Okay, I've opened my spreadsheet. The spreadsheet for this one is S model labor parentheses 2. It has the cell labor activity in there for you, and really all you need to do then is go to data. Oh, sorry, we need to change that right hand side. We're going to put 10,000. We're going to hire 5 people full time. Go to data, solver. Looks to me like it's all set up. Click on solve. And what just happened? We hired a bunch of labor. We hired 10,000 hours of labor, and what did we do with it? Well, we surely didn't grow a bunch of crops. Oh, sorry. We surely didn't grow a bunch of crops. We did use up our 600 acres, right? We grew some crops. We grew soybeans. But we grew soybeans in a way to preserve labor, because the real moneymaker in this situation is, let's hire these people, the 10,000 hours, and let's sell a bunch of it to the market. So the way this has been constructed here, we brought in a bunch of labor, and instead of letting them work on our farm, for the most part, we've just said, let's go, and you guys come work with us where we're selling labor to the market. This model, the way it's been done, has everything okay, but it's not the model we were trying to do, right? So mathematically, this all kind of holds up. Excel doesn't see any problems, and it doesn't see anything better than hiring somebody at 6 and then selling that labor to the market at 12. Buy low, sell high, right? That's this story, and this one certainly isn't going to change that story. So we did something wrong. We've got a problem. We need to fix it, and that's where we're headed now. So what is the way to fix this? This is the solution we just brought up. Solution is 10,000 hours. We used the exact hired labor limit. We're going to sell 10,170 hours. That's a good deal, but it doesn't really work. So here's some rules. You'll read these rules, I think, in the chapter reading this time, but I'm not sure. If you don't, here's the rule. If an item is perfectly substitutable inside the context of your model, right? So it doesn't have to be, you don't need to know from the data that something's substitutable. We're saying it's perfectly substitutable right here. You want an hour of family labor to go to the market? Well, if you want to replace it, it's perfectly replaceable, okay? Even if this case, we said that, hiring labor is not as good as having somebody from the farm, so a hired person's hour is only as effective as 8/10 or 80% of a family person working. Even there you have a problem, right? Because you'll still hire in 0.8 people and sell them over here, because 80% of this is more than what you're paying here. So really, when you do this, you have to be sure that if something's substitutable, when you offer to sell it to the market, you're getting less than what you can pay to bring it in, right? So there's some kind of friction or something that will stop you from buying something just to sell it. It cuts out what we call a middleman activity, which Well, typically in a linear model, it'll just run wild, right? You'll run wild up to the limit. So here we have a constraint. If we didn't have a constraint on the amount of labor you could hire, and I didn't ask you to do this, but you could try it. Just turn this constraint off and let it run. And it should say, I can't find a boundary, because you should just keep hiring labor and then selling it forever. That's the only thing you should be specialized in doing if you have this setup. A place where you'll see this is in a lot of crop models or other models where you can buy things and sell them, and they're the same thing. But the idea in production planning is really that you're either buying it because you don't want to produce it on the farm, or because you produce it on the farm and you make some excess amount, more than you can productively use, and you want to sell it. And so if you need to incorporate both of those, there's usually a cost penalty for buying something only to turn around and sell it, and those penalties, as long as they exist, will stop linear programming models or solvers from doing that. And that's really what we want to account for. So we need to make a fix. We need to make a fix to our model. Okay, so I said you can't buy. The rule is you can't buy and sell. You can't buy for less than you can sell at. And that's true, but only if in the context of your model there's a perfect substitution relationship. And so we have two choices. We can either depress the price of selling family labor, or so that it's less than the hiring labor amount, or we can de-link them. We can break them apart so that there's not this sort of perfect substitution going on where you just want to become the person who trades in labor or in hay or whatever the activity is. So you can invoke that penalty, or you can do what we've done here, and so I'll walk you through this. This is the new model. I think it's in parentheses S model labor in parentheses 3. So family labor. This family labor constraint is no longer the constraint that you contribute directly to corn. The corn activity, the soybean activity, and the wheat activity no longer look down here and say, family labor, I need 3 units. Soybean unit labor, I need 2.55. It's going to wait and move down to this labor constraint. And so the family labor is a supply constraint. How do I want to allocate the labor of my family-owned labor? There's 1,700 hours of it, and I have two choices. One, I can sell family labor to M, the market. Second, I could sell my family labor to the farm. I can sell it to the farm, and I'm not going to charge the farm anything for it. I'm just going to transfer it over and let them use it in the production plan. Selling family labor to the market uses up hours of the farm labor. And the delinking happens because the second constraint right below here is for hired labor, and it's on a separate constraint. Okay, so it's no longer the case. It's now the case that the only way for these two to substitute each other is into this third constraint where they both have a -1. So you're always doing a balancing act. Do I want to draw in my labor from this free source where there's an opportunity cost of $6.50, or here where it's 6? And so it's comparing these two, and it's going to use labor hired in first as long as you earn more than they do off the farm. If we lowered this from $6.50 to $5.50, I think that'll be in your quiz. I'm not positive, I don't have it in front of me. If you change it and lower this, what should we see? We should see a flip. We should see that you want to use up family labor first, then you'll hire in to supplement if necessary. And so that's what we're doing here. So we're doing a transfer activity. Family labor's here. It can be used two ways: sell it to the market, sell it to the farm. When we sell it to the farm, we transfer that 1 hour down here. I believe that's the next one. Or when we hire an hour of labor, we do that activity. It costs $6, and we transfer it down here. And then this last constraint, this last constraint is something we call a balance row. Okay, so this one says take the supplies, -1, -1. They go on the right-hand side, right, if you were thinking about supply and demand. So take the family labor transfers to the farm. The hired labor only goes to the farm. And these are the supply pieces that you could put on the right hand side, but because they're variables, we're putting them on the left hand side. So these are the supply pieces. Every hour you choose to contribute 630, and every hour you choose to hire in 900, there's a supply of 1530 hours going to the farm. And then the demand, 3, 255, and 24. Okay, so these usages, 0 times 3, 600 times 255, 0 times 2.4, better add up to this, because this is a supply-demand relationship, and that's why we put 0 on the right-hand side. We say that you have to account for these transfers, have to account for all of this. So you get the positive demands for use, the negative signs for hours transferred in. These will tend to, try to pull this thing up to violate the constraint, and then you incur a cost or zero cost here. It's not a zero cost, it technically costs you $650 because you have to pull it out of this side, and so it's an indirect measure of the cost. The right hand side of a balance row is always 0. Every use by a profit earning activity increases the left hand side and forces you to try to maintain less than or equal to 0 by bringing in some transfer. Call them transfer activities. This +1 -1, that's a transfer set of coefficients, and then this balance row works to keep everything, the demands, the supplies, in balance. This trade-off between the farm and market labor for the family is now entirely contained in this family labor constraint, and substitution between farm and hired labor is completely controlled down here. So we've delinked those two things, and that was the critical piece. Okay, what do we got? I should back up, I guess. Since we said we were concerned about soybean specialization being the issue before, we should be maybe concerned about it now. We've got the cost coefficients fixed, but we might have some issues. We might have some things that we would be concerned about, or some problems that would be worth looking into. And we could think about that, and whether that would be important. And I don't know that we'll get to fully flesh it all out, but we are going to come back to this for one more lecture and think about how to integrate some of these things. So two models, we really have two models in one when we flesh out that labor sell and buy choice, crop production model with a labor allocation model. We were able to accomplish that and link up the sort of crop production with the labor allocation or sales of labor model using transfer and balance. We have three activities. The activities and constraints were the key to making that work, and they're the key to making all larger models. So we tend to produce things in blocks. Those blocks tend to relate to budgets or comparative budgets, right? So you do something like partial budgeting, where you compare activity A or enterprise A versus B versus C. Well, that sort of forms one block of a model, but you may have other activities that should be considered along with it. It may not be appropriate, especially when resource base is shared among all the activities, and those indirect effects through the resource base could be very important. So we could produce crops. So thinking about this in a crop and livestock model, you might think about producing corn, hay, oats, whatever we've talked about in some of those other models. You could transfer it to the market for direct sale when you get the output, or you could transfer it to some feeding activity for use in livestock production. So essentially, you market the crop you produce, at least some of it, through the livestock that you choose to produce and sell. You'd have a balance there too. You'd have every unit of farm-produced feed ingredient that's fed to the livestock must first be produced. So you produce the unit, that's the positive. When you feed it, that's the negative. You draw down on it, and so you need a balance row for that feed agreement. In some ways, this idea of producing crops first, passing them over to the livestock section of the farm, you could think of that as not just a transfer activity, but it's actually a sort of staged or sequenced set of activities. And so in production planning, the sequence can matter. So if we were going to think about what are the issues that could arise right here in the corn, soybean, and wheat side of the model that get us away from specialization, well, one of those possibilities could be, what are the sequences? If we go back and look at the budget, you see that there's quite a few activities that are subsumed. When we put this 171 together, even after we took out the labor, there was a planting activity, a harvest activity, and a plowing and disking. So there's 4 different activities, and the sequence of those things all kind of matter. You can't allocate, you have to do something A before you can start to do the allocation among options and begin the next step B. And that sequencing or staging, that's really our final piece of building these out and thinking about sort of tricks or tools in model building. And that's what our next lecture will be. After you finish the quiz on this one, that'll be the next thing we're asked to do.